Welcome to Virtual Math Masters. I'm your favorite host, your boy Master Cruz, and today we're going to talk about the distance formula, how to find the distance between 2 points, whether it's a graph or just 2 points given to you. So here we go. At some point in some movies, you always heard, hey, we're going to travel in time. We're going to go through a black hole. And what's the fastest way to get from point A to point B? Well, it turns out that the fastest way to get from point A to point B is to draw a straight line. Well, that's not a line. Haha, just kidding. To draw a straight line from point A to point B, like that. That line right there, we're going to call it D for distance. The question that we want to ask is, how long is this line? What's the length of this line, right? So if I were to card this 1, 2, 3, this is my x-axis, -1, -2, -3, and this is 1, 2, 3, right? And this will be -1, -2, and like that. I want to know how long is this? Well, the truth is, just by looking, I cannot tell. But what I can do is find the difference between x2 and x1, find out the difference between y2 and y1, and then use the distance formula to calculate that. And then I'm going to show it to you algebraically first, and then I'm going to show this to you visually so that you could see how easy it is when you have a graph. It's a little bit easier. So here we go. Let's label the points. Point A has coordinates x, y, like every other point, right? This is always x, y. And the x value over here is -2. The y value is +1. All right. This point B also has coordinates x, y. The x coordinate right here, right, if you look at it, is +2. So let's erase that. It's +2. And the y coordinate is a +3. Up here, +3. So those are the coordinates. 2 for x, 3 for y. And then for point A is -2 for x. Let's label this y up here, and 1 for y. So now that I have x and y, I can actually label this again x and y. And the first point, point A, I'm going to call it right here x1, y1, because this is the first point. And for the second point, I'm just going to call it x2, y2. So I just add 2's to it. It does not matter which one is x1, y1, as long as you keep them together. And then x2, y2, you keep them together. So let's plug this into our formula. Distance formula actually comes straight away from the Pythagorean theorem, but let's just plug in. So I'm going to open a parentheses, and instead of x2, I'm going to write well, there's a minus sign in the middle, so I'm going to put minus. And what is x2? Well, I called x2 to be 2. So I'm going to substitute 2 in here, and it's going to be 2 minus whatever x1 is. Well, x1 here is -2. So I'm going to put a -2 in here. Then I close my parentheses and I square this because this entire thing is squared. Then I'm going to make this a little bit longer, and I'm going to put a plus sign up here because there's a plus sign in the middle. And I'm going to repeat the same process, and make sure that you put the square here as well. There's a square at the end of the x and at the end of the y. So I open a parentheses and I write y2 with a minus sign in the middle, of course. Y2 is just 3 minus y1, which is 1. And I close my parentheses, and it's all squared. Okay, so the reason why I put a double parentheses here is because this 2 was negative. So when I simplify this, hopefully you can see when I simplify this, that this will turn into a positive. We learned this before, right? 2 negatives turn into a positive. So this is really 2 plus 2, because you connect 2 negatives, negative times a negative, it's a positive. So this in reality is 4 squared. That's what that is inside of the first parentheses. 4 squared, there's the plus sign. So plus, just to make sure that everybody understand, this plus sign is this plus sign. And then we have to get one number in here. 3 minus 1 is 2. So this is going to be 2 squared. And if it was negative, it will stay inside of a parentheses. but it's positive, so it's okay for it to stay outside. If you do want to write the parentheses, it is okay. You can do this as well, and you get the same answer. So 4 squared is 16. There's 4 times 4 is 16. That's what it means. And then there's a plus sign. So plus, this is all still inside of the square root. 2 squared is 4 because 2 times 2 is 4. And this will simplify to the square root of 20. And if I ask for an exact answer, this is it. It is the square root of 20. If you have a multiple choice answer, they might simplify this a little bit more to 5 square root. Actually, I'm so sorry. The square root, let's do this correctly. The square root of 20 is the same thing as me saying 4 times the square root of 5, right? Because 4 times 5 is 20, and it stays inside of the square root. So this is the same thing as me saying the square root of 4 times the square root of 5. And the square root of 4 is just 2. And we leave the square root of 5 alone. But we're not doing that right now. So don't worry if you don't know how to simplify this part. This is enough. The square root of 20 is enough. And if you have a calculator and you want to take the square root in a calculator and give me a decimal, that it's also okay. So it turns out that the distance between A and B is this, is the square root of 20, which is 2 square root of 5 to radical 5. So if you were to put that in a calculator, and I'm actually going to put it in a calculator real quick so that I could take the square root to give you an actual decimal. I think that will be great if we do that. So I'm just going to write over my calculator 20 real quick, and I'm going to take the square root of that. And that number is 4 point, and I'm going to round to the nearest 147. So this is about 4.47. So if I ask you for a decimal or I ask you to round it, that will be the answer that you will give me. That's how long this is. But do you see how hard it is to see it from there? It's a little bit hard. Now, I want to show you something that could help you do this a little bit faster every time that you have a graph. So because you have a graph, you can find the change on X. So this is X1 and this is X2, right? How many times do I need to move to the right to get from X, from point A to point B? Well, I'm going to have to move 1 unit, 2 units, 3 units, 4 units. So this number is going to be 4 over here. How many times do I have to move up from here to get to the point? Well, I'm going to have to move 1 and 2 units. So this number is 2. If you notice, these two numbers correspond to these two numbers. Okay. So if you're able to do that, you can skip all this and go straight there. If that's too much, don't worry. Just use the points. The formula always works. What happens if you do not have a graph and you just have the points? Well, let's look at example 2. Example 2 says, find the distance between -2, 5 and 4, 1. So again, my first step, and always, it will always be to label the points. This is X, Y, this is X, Y. My first point, I'm just gonna call it 1, 1, so X1, Y1. My second point, I'm always gonna call it 2, 2, so X2, Y2, always. And then I'm just gonna come up here and copy paste the formula because it is the same formula every single time. So for my problems, I will always do this. Please feel free to do this for your problems as well. Just rewrite the formula if you feel like you need to rewrite the formula to get it correct. So here we go. I'm going to say that D equals, and I'm going to have a huge square root, and I'm going to simplify, right? I'm going to substitute the numbers that go there. So plus and open the parentheses. There's going to be minus a minus in here, and now let's substitute. So X2 minus X1. So X2 is 4. So I'm going to substitute here 4. X1 is -2. So I'm going to put here -2. Okay. And then Y2 minus Y1. So Y2 here is just 1 and Y1 is 5. So I'm just substituting and then I'm going to simplify. So this is going to be the square root of, let's simplify. This is 4. Really, this is 4 plus 2, right? Because double negatives you connect them and you make a messed up plus sign with that parentheses. So that's just 6 squared, okay, because it's 4 plus 2. And there's a plus sign here. 1 minus 4 is negative, 1 minus 5, sorry, is negative 4. So this is going to be negative 4. So because it is negative 4, I'm going to put it in parentheses, and I'm going to put a square here, and this equals. Let's simplify. So 6 squared just is 6 times 6, which is 36. There's a plus sign, so plus. Negative 4 squared is negative 4 times negative 4, which is positive 16. Okay, so this will be positive 16. And then this will simplify to the square root of 52, right? So this will be the answer, the square root of 52. Now, if I ask you to simplify this even more and give me a decimal, right, then you will put this into the calculator, hit that square root button, and if you do that, this is going to be, it's not going to be equal anymore. It's going to be approximately, right, approximately 7.21. So that's what it equals if you take the square root of 52. And the reason why we're getting this is because there's no number that you multiply times itself to get 52, right? Like if the answer would have been the square root of 16, I know that the final answer, it's automatically 4. If the answer would have been the square root of 25, I know that the answer is automatically 5, because 5 times 5 gives me 25, and 4 times 4 gives me 16. However, there's no number that when you multiply times itself gives you 52, so the answer will be a non-terminating decimal. So this is an approximation, is not an exact number, it's an approximation. And that is how you use the distance formula, and you find the distance between 2 points. If you need additional help, please visit virtualmathmasters.com. I'm your boy, Master Cruz. I can give you help, personalized help with everything that you need math related. Claim your free tutoring session, and I'm your boy, Master Cruz, so you never do math alone again.